Okay guys, I'm going to work out 2 or 3 Hess's law problems. So that's a thermodynamics topic. You're given the enthalpy of formation or enthalpy of this reaction. Sorry, not formation, enthalpy of the reaction over to the right. This one you have not been given the final equation, but let's say you're given to reaction and asked to write what the final reaction would look like. Basically what you want to do is scratch out anything that shows up on the left side as a reactant and as a product in another equation. So you're just looking to scratch out one on each side if they match. So here the only thing that matches is CO is a product in the first step, and in the second step it's used up as a reactant. So again, we talked about this in our meeting that's called an intermediate. It's produced in the first step, used up in the second step. So in that situation, everything that I have now won't cancel out. So I can just write an overall reaction. You have your 2 reactants. 2 halves means you actually have 1 O2, and then CO2 is your product. So all you have to do to calculate the overall enthalpy of the reaction is add these 2 values together. You did not modify your equations in any way. You just canceled stuff out, so you just add these 2 numbers together. So when you do that, I get negative 393.5, and the unit there is kilojoules. First example. The next example is one like we worked today, where you're given an overall reaction, and here are the 3 steps to get there. If you modify this equation at all, then however you modified it here, you must modify the delta H value that goes with it. So what you want to look for, you're not going to have this on a piece of paper that you can scratch out, and you're not going to have time to rewrite it. So you just kind of want to look for, what do you need to change? What do you need to rearrange? So you're trying to get C2H4 as a reactant, and here in this equation, he's a product. So the first thing you would need to do is reverse him. So you would basically reverse him, and without writing it out, you just know that if I reverse that reaction to get him on this side, then this becomes negative. Okay? Then you need 6F2 on the left side. You have F2 already on the left here. We'll leave him, but this F2 is on the right side, and you need him to be on the left. So you're going to reverse this reaction. So you would reverse this reaction, so he'd end up over here. That means you have to reverse your delta H value, change the sign. So you've got these 2 flipped around, but then you have to look back at your numbers. You need 2 CF4s, right? So when you reverse this reaction, your CF4 ended up on this side, but you need 2 of them. So you can't multiply one part by a value. You can only multiply the whole thing. So you're going to multiply this whole thing by 2. And that would give you 2 CF4s, 2 Cs, and 4 F2s. Now when you multiply this by 2, you must also multiply this by 2. So we're going to multiply him by 2. You still need 4 HFs. So we're on our last thing. We went through each part of our final reaction. You need 4 HFs on the right side, and the only way to get 4 HFs right here is to multiply this whole thing by 2, which would give you 2 H2s, 2 F2s, and 4 HFs. Same thing. You multiplied that by 2, so you must also multiply this by 2. So now you have everything worked out. You've accounted for each part of your final equation. If you go down through here, you don't need the H2s, and when you reverse this H2 and this H2 would have canceled. You do not need carbon, because carbon is not in your final reaction. So if you notice, you now have 2 carbons, and once you reversed this, then your carbons would end up canceling each other out. So now you have everything left that you have in your original equation. You have one C2H4, you have 6 F2s, right? So you've got 2 here and 4 here, so that adds up to 6. You have 2 CF4s, you have 4 HFs. So you've canceled everything out and everything matches to your final reaction. So now all you have to do is add this up. So you would have your overall reaction. Now, since you can't, if you're not asked to rewrite this all out on an FRQ, if you're asked to just look at it and determine the overall formation or the overall delta enthalpy of reaction, then you simply change your values and write out your problem. That's how you're going to get the point. They want to see that you knew what to do, that you took that reaction and multiplied it by 2. You reversed this reaction, and then you reversed this reaction and multiplied it by 2. So you would just add all that up. So I get negative 1,074 minus 52 minus 1,360. So when you add all that up, I get negative, you want to say delta H reaction equals negative 2486 kilojoules. And you have no decimal points, right? You're doing significant figures and you have no decimals, which means your final answer would have no decimal because you're adding. All right, so one more. Here you're given 2 reactions and you're given a final equation, so you just kind of want to go by the easiest way to do it without rewriting everything and switching everything around on paper, because you don't have time to do that. It's to simply look at your final reaction and what you need. So here you need 2 F2s and you need those to be on the left side. But up here in your equations, F2's on the right side. So you need to reverse him. So you would reverse him. And you would need to multiply him by 2 because you need 2 of them. So you'd have 2 HFs, 2 H2, 2 F2s. I'm sorry, there was a typo right there. That's actually supposed to be 302 for some reason. No, it's not. I lied. Let's leave it like that. So you got your F2 taken care of. So you have to fix your value. You reversed it. And you multiplied it by 2. So that takes care of your 2F2. Now you need 2 H2Os on the left. You have 2 H2Os on the left. So leave that alone. You need 4 HFs on the left. You have, oh, I had this written wrong. That's what I had written wrong. I'm sorry. This was a 2 already. It was supposed to be 2 HF, and then I was multiplying it by 2, so that would make it 4 HF. I'm sorry. So you fixed that. You got your 2 F2s, and you have 4 HF. And then the last thing you need is an O2 on the right, and you already have an O2 on the right. So you didn't actually end up having to do anything to the first equation, but on this one, we reversed it, and we multiplied every coefficient by 2. We reversed it, multiplied everything by 2. So now you should just be able to cancel anything out or have everything that you're supposed to. You have 2 F2s on the right where we reversed it, 2 H2 on the right, 4 HF that we reversed is now over here, and then your O2, and the thing that cancels out were your H2s. Once we reverse this, then you have 1 on the right side, 1 on the left side. 1 on the left side, 1 on the right side. So now you're just adding this up. So when you work this out, overall 572 plus negative 542 times 2, it ends up being negative 512 kilojoules. So 3 examples of Hess's law, and I have a worksheet that I can email you that has several examples and has the overall answer. So you can just look at that, pick 2 or 3, go down, work a couple of them, see if you're getting the right answer, if you can cancel everything out the right way, to practice that.